This is section 12.2, IM2. The warm-up is truly just taking a graphing calculator and graphing these. I'm sure that you understand now how to do that, hitting the y equals button and all that kind of stuff. What I want to focus on right now is this. This blue function. Please tell me, does this function right here open up or down? Up. Okay, absolutely. It does open up. All right? This red function here, up or down? Down. Now, the smart board is not going to indicate any kind of arrows, so I'm going to draw those on. All right? So those are two quadratics. We begin with a tough problem today, and the problem, well, it's not a difficult problem. However, we're dealing with area again. All of these area models in quadratics have this very, very close relationship. So it says here, two dog owners have 16 yards of fencing to build a dog run beside their house. The dog owners want the run to be in the shape of a rectangle, and they want to use the side of their house as one side of the dog run. We've got a rough sketch here. Kind of seeing, and you'll notice, do we need any kind of fence on this side? Not at all. We need fence here. We need fence here, and we're going to need fence on this back side. Okay. So somehow we want to first, in your book right now, okay, on this page, on page 866, they are asking us to write a function L of W. Okay, let me zoom in so you can see this, even in the video. Zoom in just a little bit. We want find this function L of W that represents the length of the dog run as a function of the width. Please, you should by now be able to read that and know they want L of W is equal to, and whatever we get over here is going to have what in it? W. Because it's written in terms of W. So how do you think the width and the length of this thing relate? What is their relationship? Yes? They should add up to 16? Okay. Well, how many lengths are there? 1, 2. How many lengths are we worried about fencing? 2. Folks, we're worried about 2. Yes. We're worried about this one and this one. And the width, there's one width. How many feet of fencing do we have to work with? 16. So we have 2 lengths plus 1 width should add up to 16. But folks, they want the function written in terms of W, so they want the L all by itself. Do you think you can figure out what to do there? Go ahead, what would you do? Subtract 2L, yes. If you subtract 2L, okay, I'm going to bring my work right down here now. We should have L of W now, so the length in terms of W is equal to 16 minus 2L. Oh, yeah. No, wait, not 16 minus 2L. We have, it's going to be W. Wait. Okay, what did we just do wrong? We did everything just wrong just now. We got W alone. What did we want to get alone? Okay, you can laugh at me in the recording after. All right, I'm going to erase this because, hey, maybe that'll happen to you, but I don't want to get W alone. I want to get L alone. So I'm going to now subtract W. And what I end up with, I'm going to bring my work down here if you don't mind. So I have 2L is equal to 16 minus W. And now what do I do to get L alone? Help me out. Divide by 2. Good. Now we're right on track. I got the wrong thing isolated. Wrong variable. We've got L is now equal to 16 minus W all over 2. That, ladies and gentlemen, is L of W. You don't have to write L. You can write L of W, the length in terms of the width. Yes?
Can L of W also equal 8 minus W?
No, it cannot. It cannot. Another way to write this could be this. L of W is equal to, well, what's 16 divided by 2? 8. Minus, but this 2 also has to divide into the negative W, so it would be minus 1/2 W. That would be the same. But I got to be honest, I would just leave it as 16. Here, let's move these out of the way. I would just leave it as 16 minus W all over 2. Okay. Now, it's part of your job to really understand what's happening here, so they made this table for a reason. They have the width. They give you some examples of the width. And how about let's zoom right in here. Let's head over to this table. If the width is 0, what do you think the length is? What do you think the length is if the width is 0? 8. Because you have 2 lengths, correct? 2 lengths. You have to have 8 and 8. And I realize that doesn't make really intuitive sense, but hopefully you understand we have 2 lengths. You can see it right here. We have a length here and a length on the back side. So if this was 0, if your width is 0, then your lengths have to be 8. All right, now, question, what are the square yards? Yeah, because, folks, length times width, 8 times 0 is 0. Good. Picturing it, hopefully. Watch the next one. This next one, right here. If the width is 2, remember you have 2 is just, there's one width. Well, what would that be? 7, good. Because there are 2 7s, which is 14. 14 and 2 is 16. That's total fencing, and that's the length of fencing we have. Area, 14. All right, now what if the width was 4? What's the length? 6. What's the area? 24. And I'm going to just kind of totally reveal this so you can see. We'll save some time here. Okay. Now, I don't know about you, but I bet you could look at this table and get a nice idea of what you would set your window to. And you could also get an idea of what dimensions give you the largest amount of space for this dog to run around in. The maximum area. Yes, Lucas.
For the width of 16 and length of 0, wouldn't the area be undefined? Because you cannot divide 16 by 0. Or I'm actually, never mind.
Okay, gotcha. Totally understand. But yes, 16 multiplied by 0, then we would have it's not even actually a polygon at all. It's not even a shape. Okay, it's just a line, really. Okay, let's kind of move down here. We'll move on to the next one here. Page 867, number 8. All right. Now, I'm going to just kind of hide this for a moment. I know you're kind of looking at it, but I'm going to hide this. You kind of got a little peek at it. They are using this this little grid here to help you determine your window on your calculator. So let's talk about this for a moment. We've got this problem, and it's the same dog run problem. And what do you think the lower bound of the width was? What's the least the width could be? Do you agree, 0?
Yeah.
Right? Now, according to that table that we just did, what was the upper bound of the width? Upper bound of the width. 16? So you're looking at this, and we were all just looking at it going, hey, I thought the upper bound for the width would be 16, right? And you are right. But what we're looking for is we're looking for a nice window on the calculator. Do you think that if I use 20 on the calculator, it'll fit the 16 inside it? Yes. That's what we're going to do. Now let's talk about this interval right here. This interval. What they're saying is, hey, determine possibly what you want your width to actually increase by on your graphing calculator. Do you want it to go by 1s? Do you want it to go by 2s? In this case, they chose just to go by 2s. You don't have to. You don't have to at all. Lower bound, area. What was the lower bound for the area? 0, right? But what was the upper bound for the area? 32? Hey, let's just take a guess. What do you think they put?
40.
40? Let's see. 40. Yeah, they picked something really nice so that everything fits inside your window beautifully, right? Interval. What do you think they want to go by? How'd you know that? Yeah, 4. Okay. Oh, they're going by 4s. Yes. This is the tough part, and there is something underneath here. It is the function a of w. But please tell me, guys, the area in terms of w, do you agree that we find area by using length times width? Yes? Back on the last page, if I double page this right here so you can see it, back on this last page, I have that the length, L of w, is equal to 16 minus w all over 2. That right there is the length. Okay, come back here. This is the length. How would I actually find out what this function is? A of w is equal to something, but only in terms of w. I don't want L and W in there. No L there. I want just W. What would I do? No? Guys, do we have the length in terms of W? Do you have the length in terms of W? We certainly do. It's sitting right here. The length is equal to 16 minus W over 2. Can't I take this and have it take the place of that L right there? Yeah? Absolutely I can. All right, so watch carefully. A of W is equal to L times W. I'm going to take this L and I'm going to substitute. L is really equal to? So 16 minus W all over 2 inside parentheses and then multiply by W. Yes? Can I distribute? Got to break out those algebra skills, though, right? Okay, question. This W, is this W in the numerator or denominator? Numerator or denominator? Come on, numerator, right? So there's really a 1 underneath. You don't have to write it there, but it does help usually, visually, how we're going to distribute. This W, should I distribute it to the 2? No, just in the numerator. So here we go. A of W is equal to, what's 16 times W? Good, 16W. Then W times negative W is minus W squared all over 2. Good. Don't multiply the W and the 2, please. Hey, we've got a quadratic. And you can write it in standard form if you feel like it. In standard form, it would just look like this. A of W is equal to, grab this part first, right there. Do you agree that's minus 1/2 w squared? When you divide by 2, that's like multiplying by a half. So it's minus 1/2 w squared. And then here, what would this part be? Plus 8w. Yeah. Doesn't matter which one you want to use here. They're both the same. This one is just in good old standard form. All right. So underneath this question mark is this function. Okay? And we came up with it. Logically, we pretty much derived it, right? Now I'm going to graph these, and I'm sure that you could graph it on your calculator if you wanted to, making sure that you have the parentheses correct. I'm going to take this, and on the smart board it has this nice tool just to graph quickly. But please right now, take a moment to graph it on your calculator, and I'm going to also. All right, so I'll clear everything out of my last one. There is somewhat of a guarantee I'm going to give you right now that many of you might not enter this correctly, and that's okay. This is something to learn from right now. Go ahead, question?
Is it alright to just not have it as a fraction, keep it in the standard form of negative 1/2 w squared plus 8w? Is that okay?
Oh, absolutely. You can leave it like that in standard form. It's up to you. Really does not matter at all here. So I can actually graph both and make sure that they look the same. Here we go. I need to open parentheses. Here, if you're watching this video, I want to make sure that I have the large screen here. So open parentheses, 16x minus, and then x squared, close my parentheses, and then I have to divide by 2. Do you see how important those parentheses are? Okay, yes?
Can you just do alpha like equals? And then
Okay, that is completely awesome. Yes, here's another way. If you have the new TI-84 with math print, you can go alpha, y equals, and there is a fraction up there. You enter the fraction, and now we have 16 x minus x squared, and then you drop down to the denominator and just divide by 2. Isn't that nice? That's how it should look. Okay, next one. Hey, what was the standard form of this thing?
Negative 1/2 w
All right.
squared.
So I'm going to actually use the math print again, so it looks really really nice here. So this is going to be 1/2, but I'll jump out in front for a moment, and I'm going to insert a negative. And that's going to be x squared, right?
Plus 8x.
Plus 8x, so plus 8x. Now when I hit graph, I probably am not going to be in a nice window, am I? Now we already know what the window is. We've set upper bounds, lower bounds. So I'm going to go over to my window. The x min, I always like to set it to the negatives just so I can see everything. X max, what would you say that was, yes?
How do you do what you just did on like the, I only have the 83.
83 doesn't do that.
I know, but like how would you do it if you have the 83?
Okay, on the TI-83, here's the question. How would you enter that? You would enter it like my top one. This is how you would enter it on the TI-83. Okay. All right, next. All right, head over to window. What'd you guys say for the X max?
20.
20? All right, there's my 20. Now you can set your X scale, whatever you want it to go by. They said 2. I don't care about that. I'm going to leave it at 1. Y min. I'm just going to go -5 just so I see everything. And then Y max. They said 40. Okay, 40. And I'm going to graph. How many, you guys were watching, how many equations did I enter in? 3. So it's going to graph all 3 of them, but in different colors. So look at this. When I hit y equals, the first graph is going to be in blue, then in red, then in black. Let's see what happens. Here we go. Blue. Red. And black. Aren't they all the same? Just different visual representations of the same quadratic function, right? Yeah. You have to admit that's pretty cool.